According to the U.S. Food and Drug Administration, FDA, some tortilla chips may contain high levels of acrylamide, a compound that may increase cancer risk. Are these concerns valid? What's the truth? Tortilla chips originated in Mexico and became popular in the U.S. in the early 20th century. Legend has it the snack was born by accident in the 1940s when Rebecca Webb Carranza, owner of a tortilla factory in Los Angeles, decided to fry and sell leftover tortilla scraps as a snack. The idea quickly took off and grew into the billion-dollar industry it is today. Major brands like Doritos, Frito-Lay, Tostitos, and Mission Foods now dominate the market, offering a wide variety of flavors and ingredients to attract consumers. So how are tortilla chips made? The journey of a tortilla chip starts with dried corn, but it's not just ground up. First, the corn undergoes nixtamalization, an ancient Aztec method. This involves soaking the corn in lime water, calcium hydroxide, at 80 to 90 degrees Celsius for 8 to 14 hours. The goal isn't just to soften the hulls, but also to release niacin, vitamin B3, to boost nutritional value. Improve texture for a pliable, sticky dough. Develop the signature tortilla flavor. After soaking, the corn is rinsed to remove loosened hulls, then ground by high-capacity mills using counter-rotating stone rollers. The result is masa, a moist dough with about 50 to 55% moisture, ready for shaping. The masa is fed into an industrial roller, where it's flattened into even sheets about 1 to 2 millimeters thick. These sheets then pass through a cutter. A metal drum with shaped molds rolls over the dough, slicing it into triangles or rounds, depending on the chip design. Scraps from the cutting process are collected, remixed, and reused in the next batch. The shaped chips are conveyed into a pre-baking oven set to 200 to 250 degrees Celsius. They're baked for 30 to 60 seconds, just enough to dry the surface and help maintain shape during frying. At this stage, the chips are still soft, not yet crunchy. From the oven, semi-finished chips go directly into oil fryers. Oil is kept at 175 to 190 degrees Celsius, and frying lasts 30 to 60 seconds depending on chip thickness. This step is crucial to completely remove remaining moisture for a crisp texture. create a porous, airy structure via rapid steam expansion. Enhance flavor with light oil absorption. Some brands use hot air baking instead to reduce fat content. After frying, chips are cooled and moved into rotating drums for seasoning. Seasonings are usually dry powders, salt, cheese, chili, onion, garlic, or natural artificial flavors. A spray or shaker system ensures even coating. A thin layer of oil may be applied first to improve adhesion. Finished chips pass through an automated camera check to reject burnt, broken, or misshapen pieces. If tortilla chips were born from the need to reuse leftover ingredients, then cheese puffs were the result of a production accident. A minor operational error, a batch of dough mishandled. But the result was not a failure. That very coincidence gave birth to one of the most beloved light and crispy snacks in America. Cheese puffs, also known as puffcorn, were created by accident in the 1930s at a livestock feed factory in Wisconsin, USA. During the operation of the extruder, a worker discovered that leftover cornmeal inside the machine, already compressed and heated under high pressure, was being ejected as unusual puffed shapes. This wasn't the intended product, just compressed residue being forced out. Instead of discarding it, they curiously tried baking it again, adding spices and powdered cheese. The surprising result, a product with a light, crispy texture and an appealing flavor. Sensing the potential, food companies like Flacol Corporation, later Old London Foods, began commercial production of cheese puffs, creating a completely new segment in the snack industry. Today, major brands like Cheetos, Frito-Lay, Pirate's Booty, and Utz have made cheese puffs a staple in the global snack industry. In September, across the Midwest of the United States, golden dent cornfields gleam under the gentle late summer sun. Harvesters collect the ripe, heavy corn ears, sending them straight into large collection bins. But that's only the beginning. At the nearby pre-processing station, the corn ears are fed into a kernel separator. Powerful rotating drums strip the kernels from the cobs in seconds. The kernels then flow down a screening chute where strong air currents blow away silk and light debris. A conveyor system then moves the kernels through vibrating sieves to eliminate sand, stones, and shriveled kernels. If the moisture content is above 14%, the corn is briefly dried in a hot air chamber to reduce moisture to about 12 to 13%, the ideal range for preservation without cracking. Only after passing all these stages are the selected kernels transferred to giant steel silos, where temperature and humidity are strictly controlled. Only then are the kernels sent to the processing plant. There, the dried corn is ground into ultra-fine powder, ready for the extrusion step that shapes the snack. From storage tanks, the dry cornmeal is fed onto a conveyor and into a giant extruder. Inside, two counter-rotating screws continuously push the powder forward, compressing and heating it through friction. Under intense pressure and high temperature, the meal softens. As it is forced through a small die, the water in the meal rapidly vaporizes, puffing the dough into long, airy snack strands. On the conveyor, the puffed strands pass under a sharp rotating blade. The spinning blade cuts them into short segments about 3 to 5 centimeters in length, dropping them with a soft plop onto a dryer belt. Inside the dryer, temperature is divided into 3 gradually increasing zones. Hot air blasts from below, evaporating any remaining moisture. The entire journey through the dryer takes just a few minutes, enough to make the snacks crispy, firm on the outside but not burnt. Exiting the dryer, the snacks are light, pale yellow, and make a crackling sound as they fall into collection trays. This is the first checkpoint. Technicians check samples to ensure the moisture level is down to 2 to 3%. Just enough to keep the puffs crunchy but not fragile. After drying, the slightly cooled snacks are dumped into a large rotating drum. A fine mist of vegetable oil is sprayed evenly onto the surface, helping the seasoning adhere better. Next, a mix of powdered cheese, salt, onion, and garlic powder is dispensed steadily from overhead pipes. Mixing paddles gently tumble the snacks with each drum rotation, ensuring each puff is coated in a smooth golden cheese layer. The air here is rich with the aroma of melted cheese. Technicians watch closely to ensure even coverage. No piece left white, none overly seasoned. After coating, the snacks pass through a rapid cooling system using chilled air to stabilize their structure. A soft whooshing sound fills the room as each batch gets ready. An automated conveyor feeds the snacks into a packaging machine. Each bag is precisely weighed, flushed with nitrogen to replace oxygen, preventing moisture and maintaining crispness. The bags are heat-sealed quickly, expiry dates printed, and then stacked neatly onto pallets. Every step runs continuously, swiftly, but with precise detail, so that when you hold a bag in your hand, the puffs inside are still crispy and full of rich cheese flavor, just like when they left the factory. Each year, Americans consume over 6 billion bags of cheese puffs, according to the Snack Food Association in 2023. According to the National Pretzel Association, nearly 1.5 million pounds of pretzels are consumed daily in the U.S. Cheese puffs, light, cheesy snacks, are addictive enough. But pretzels, those seemingly simple twisted baked goods, hide little-known secrets. Few would guess that, to achieve their glossy brown crust, every pretzel undergoes a chemical dipping step, using a solution that can corrode skin if mishandled. It's no accident. It's a required step to produce the crisp, savory flavor that millions of Americans enjoy every day. So are pretzels really that simple? Or just an intricate piece of industrial magic under layers of flour and salt, pretzels are not a new invention. Their origins are believed to date back to the 7th century in European monasteries, where monks twisted dough to resemble folded arms in prayer. From there, pretzels spread across Germany, becoming a symbol of good luck, and eventually traveled with immigrants to America. Especially in Pennsylvania, still considered the pretzel capital of the US today, the pretzel industry has grown into a billion-dollar market. From a humble monastery snack, pretzels have become a cultural icon. But to mass-produce millions daily for the modern market, the process has changed drastically. We visited a large factory in Pennsylvania, where the journey from flour to pretzel begins. Everything starts in a large mixing room, where motors hum steadily all day. White flour is pumped directly from silos into mixing tanks. Operators add warm water, yeast, and salt, all precisely measured to the kilogram. For proper pretzels, the dough must maintain about 60% hydration, moist enough to twist but firm enough not to crack during baking. If the formula deviates by even a few percent, the result will be hard or crumbly pretzels. As a technician puts it, dough precision means pretzel precision, a golden rule in the industry. The heavy dough is placed into large trays and moved into a proofing chamber. Air is kept at 30 degrees Celsius with humidity around 75%. Over about 40 minutes, the yeast activates, creating tiny gas bubbles that gently puff the dough. If fermentation is too fast or too long, you won't get pretzels. You'll get something between sandwich bread and rubber. That's why every batch is thoroughly inspected before moving on. From the proofing trays, the dough heads to an automated shaping line. The dough is cut into long, narrow strips, each weighing around 50 grams. A lightning-fast robot grabs each strip and twists it into the classic pretzel shape, in under 2 seconds per piece. Misshapen pretzels are automatically detected by a camera system and removed from the line. This is the little-known and most controversial step. Raw pretzels are quickly passed through a bath of 4% sodium hydroxide solution with a pH of around 13 to 13.5, according to the US Snack Baking Industry Standard 2023. The dip lasts just 3 to 5 seconds. But it's the key to achieving that signature brown crust. Skip this step, and the pretzel will be pale like steamed bread. Immediately after dipping, pretzels go straight into an oven set above 218 degrees Celsius. According to the FDA, 2019, this temperature is sufficient to break down any remaining sodium hydroxide, converting it into sodium carbonate, a food-safe compound. Inside the oven, temperatures range from 215 to 225 degrees Celsius. Over 8 to 10 minutes, the outer crust dries and turns an appetizing glossy brown. Exiting the oven, the pretzels are quickly cooled with cold air, then topped with sea salt or sesame seeds, depending on the variety. Finally, the pretzels are batch weighed, packed into moisture-resistant plastic bags, and flushed with nitrogen to preserve crunch for 6 to 9 months. From crispy pretzels, we move to another American icon, bacon. Just 2 slices of bacon per day, according to a 2015 warning by the World Health Organization, can increase the risk of colon cancer by 18%. and commercial bacon in the US is classified in the same carcinogen category as tobacco and asbestos. Group 1. Foods proven to cause cancer in humans. So why do Americans still consume over 6 billion pounds of bacon annually, according to the US Department of Agriculture in 2023? From a simple breakfast side to a national icon, bacon has become inseparable from American culture. But what really lies beneath that crispy, savory layer? Since ancient Rome, people have preserved pork belly with salt and smoke to last through long winters. That technique arrived in America with European immigrants, where bacon quickly became a staple of the farm breakfast, a simple but essential energy source for labor-intensive days. By the early 20th century, with the rise of modern processing plants, bacon took a new turn, from artisanal food to mass-produced industrial product. Since then, most bacon sold on the market is no longer wood-smoked naturally. It is created on giant cold processing lines with steps like gas pumping, additive soaking, and thermal treatments, all designed to replicate the familiar color, flavor, and crispness. But how exactly is a commercial bacon slice made? The journey begins here. The journey of a bacon slice begins at the processing plant, where pork bellies are stacked onto chilled conveyors. Workers line up on both sides, grading each slab of meat by hand and trained eye. A pork belly that meets USDA meat standards. 2023 for commercial bacon must contain around 50 to 60% fat, with the rest being lean meat in alternating layers. If there's too much fat or uneven distribution, the slab is rejected or used for lower-grade meat products. The consistency of fat marbling determines not just the appearance of the bacon slices, but also the eating experience. Crispness, fat rendering while frying. Bacon producers invest billions in that experience, where each visually perfect, crispy slice helps retain customer loyalty. After grading, the approved pork bellies move to the injection area. A massive steel machine rumbles as hundreds of fine needles pierce deep into the meat, injecting a solution of salt water, sugar, sodium nitrite, and phosphate. The solution makes up about 10 to 15% of the raw meat weight, according to the American Meat Science Association 2023. Too little, and the meat spoils quickly. Too much, and the bacon shrinks or loses structure when cooked. Sodium nitrite helps maintain the meat's natural pink color and controls harmful bacteria like Clostridium botulinum, a major risk in processed meat. However, as noted in the 2015 World Health Organization report, when heated, sodium nitrite can form nitrosamines, a group of compounds linked to colon cancer. The food industry has developed various methods to reduce nitrosamine levels during bacon production, but whether these risks are fully mitigated remains a subject of ongoing research and debate. After injection curing, the meat is placed in a cold room to rest for 6 to 24 hours, allowing the solution to evenly penetrate. Next comes the flavoring stage. But instead of traditional wood smoking, today, according to USDA data 2022, up to 80% of commercial bacon in the US uses liquid smoke spraying, a type of smoke essence mixed with mist, sprayed directly onto the meat in a sealed chamber. After just 1 to 2 hours of treatment, the meat acquires its familiar aroma and light brown hue. The natural smoked scent you perceive is, in fact, carefully engineered, not a result of time or real fire. Once enough flavor and aroma are developed, the meat moves to a forced heat cooking chamber. The core temperature of the meat must reach between 62 and 65 degrees Celsius, according to USDA Bacon Production Standards 2023, to meet food safety requirements. Immediately upon reaching the target temperature, the meat is transferred to a forced air chilling area. A stream of cold air at -4 degrees Celsius blows directly onto the meat block, locking in the protein structure and color. Gone are the days of hanging meat to air dry like in past centuries. Here, everything, heat, cold, time, is measured to the minute, to the degree. The chilled meat is transferred to a high-speed slicing machine. An ultra-sharp steel blade spins continuously, cutting the meat into thin slices between 1.5 millimeters and 2.5 millimeters thick. Slicing speed can reach up to 400 to 500 slices per minute. The bacon slices are then neatly stacked, vacuum sealed or flushed with nitrogen gas to stay fresh longer. From slaughterhouse to finished packaging, the entire industrial bacon process today takes less than 48 hours. Tortilla chips, cheese puffs, pretzels, bacon, all familiar. Yet behind each snack lies a complex industrial production system that few truly see. Every cut, every crispy layer is the result of technology, calculation, and speed, not just simple corn, flour, or pork. Hi, if you want to keep exploring the secrets behind the world of industrial food, don't forget to subscribe to Captain Discovery. The next stories will be even more fascinating.